Stress has long been understood as a contributor to physical and mental decline, but emerging research reveals that it is not stress itself that determines aging outcomes. It is how individuals respond to stress. Among centenarians and other long-lived individuals, what consistently stands out is not a life devoid of hardship, but rather a life marked by exceptional psychological resilience, stable physiological stress responses, and a capacity to recover from adversity. These traits appear to modulate the biological toll of stress, influencing hormonal regulation, immune function, and even the pace of epigenetic aging. At the heart of the stress response lies the hypothalamic pituitary adrenal (HPA) axis, a hormonal cascade that culminates in the release of cortisol, the body's primary stress hormone. While short-term cortisol spikes are essential for acute adaptation, enhancing alertness, energy availability, and immune readiness, chronic elevation of cortisol has been linked to a host of negative health outcomes. These include impaired immune function, increased abdominal fat, insulin resistance, and neuronal atrophy, particularly in the hippocampus, a brain region critical for memory and emotional regulation. Intriguingly, centenarians tend to exhibit lower baseline cortisol levels, as well as a more moderated response to acute stress. This hormonal profile suggests a preserved capacity for stress adaptation without the harmful overactivation of the HPA axis. Studies of centenarians often describe them as calm, optimistic, and emotionally stable individuals, traits that may reflect both innate personality factors and lifelong coping strategies. Rather than avoiding stress altogether, they tend to engage with challenges pragmatically and rebound effectively, qualities increasingly recognized as essential for long-term health. This trait of resilience, defined as the ability to maintain or quickly recover homeostasis in the face of adversity, extends beyond psychology. On a biological level, resilience influences the regulation of stress-responsive systems, including the autonomic nervous system, inflammatory pathways, and DNA repair mechanisms. For example, individuals with high resilience often show lower levels of pro-inflammatory cytokines, such as IL-6 and TNF-A, following stress exposure and a quicker return to baseline after perturbation. These responses reduce cumulative inflammatory damage over time, a critical factor in preventing chronic diseases associated with aging. Another emerging area of interest is the impact of stress on epigenetic aging, changes in gene expression regulation that accumulate with time and can be measured by so-called epigenetic clocks, such as DNA methylation patterns at age-related CPG sites. Chronic psychological stress has been shown to accelerate epigenetic aging, particularly in individuals exposed to early life trauma or long-term caregiving burdens. Conversely, people who demonstrate greater psychological resilience or who practice stress buffering behaviors, such as mindfulness, social support, and exercise, often exhibit slower epigenetic aging trajectories. Remarkably, the epigenomes of centenarians and their offspring often reflect a biological age younger than their chronological age, hinting that their bodies have resisted the molecular corrosion typically driven by stress. The long-term effects of stress are also evident in disease onset and progression. Chronic stress is associated with increased risk for cardiovascular disease, depression, type 2 diabetes, and Alzheimer's disease, all of which share underlying inflammatory and metabolic pathways influenced by cortisol and sympathetic overactivation. Yet in centenarians, the delayed onset or outright absence of these conditions suggests a lifelong pattern of adaptive stress regulation, possibly influenced by favorable genetics, but clearly reinforced by behavioral patterns such as optimism, community involvement, physical activity, and daily routines. It is worth noting that some stress exposure, when moderate and well managed, may actually promote resilience through a process known as hormesis. Mild psychological or physical challenges can stimulate cellular repair, immune readiness, and cognitive flexibility. Long-lived individuals often have histories of hard work, personal loss, or societal upheaval, but rather than being overwhelmed by these experiences, they appear to have developed internal mechanisms to grow stronger. This dynamic reappraisal of stress as a challenge rather than a threat may shift physiological responses in a protective direction. Ultimately, the evidence suggests that resilience, not the absence of stress, is what predicts longevity and well-being. Psychological traits such as conscientiousness, emotional regulation, and purposefulness correlate with not only mental health, but also reduced inflammation, stable cortisol rhythms, and slower biological aging. As research into the psychobiology of aging expands, Interventions aimed at building resilience through cognitive behavioral strategies, social engagement, exercise, and purpose-driven living may offer potent tools for extending both lifespan and health span. In studying the lives of centenarians, we find not people sheltered from the turbulence of life, but individuals who have learned to navigate it with equanimity and purpose. Their example reframes the aging conversation. Stress is not the enemy, but rather a signal, one that, when interpreted and responded to skillfully, can shape a life not just of length, but of depth and vitality.